So we have another problem here from 1.6 on solving for a specific variable. So in this case, we want to solve for p. So when we have variables in the denominator, multiply by the LCD. So that's just, in general, variables in the denominator, and you're solving, multiply by the LCD. So in this case, that's just p minus f. So we'll multiply both sides by p minus f. Okay, on the left, I have to distribute this cube. So QP minus QF equals PF. Now, what variable are we solving for? P. So we should put those on the same side. So I'm going to subtract PF from both sides. So on the right, I'm going to have 0 right now, but that's okay. It doesn't really matter what order you put these. So I know that I have two p's here on the left, so I'm going to want to factor out a p, but I need to move that qf first, because that I can't factor out a p from the qf. So I'm going to move that qf over. And now that I have the p's on the same side, I have more than one, I can factor out a p. So if I factor out a p, what am I left with on the inside? Q minus f, good. And then what do? Yep, then divide by q minus f. So p equals qf over q minus f. Questions about that? All right, now we're going to look at solving radicals. Solving radical equations. So to solve a radical equation, you want to get the square root, you want to get the radical by itself. So then you could square both sides to get rid of it. So the first thing I have to do is divide by -2. So I'm going to divide both sides by -2. Oh. -10 divided by -2 is +5. Okay, so your square root a for x minus 1. So the inverse operation of a square root is square. So we can square both sides. No, so you do plus or minus when you draw in a radical. So when you square root, you do plus or minus, but not when you square. So then I get 4x minus 1, I get what's underneath, equals 25. Add 1 to both sides. And divide by 4. So that should give us 13 over 2. Improper fractions. So, like rationals, you have to check radicals. You have to check for extraneous solutions when you do radicals and rationals. So if you have a square root or variables in the denominator, you have to check for extraneous solutions. When you do the radicals, you actually just plug it back in. And make sure that it works. So 4 times 13 over 2 minus 1 is 25. Negative 2 times 5 is negative 10. Okay. With rationals, most extraneous solutions you can tell by your disclaimers. Okay, but with radicals you need to plug them back in to check. Okay. All right, let's look at another one. So you want to get the radical by itself. Get the radical by itself first. So I have to subtract x. And then square both sides. So when you square a square root, you get what's underneath. On the right side, I have a binomial. So you either need to write it twice and use FOIL, or use the shortcut if you remember it. So we've written the shortcut in our notes several times. But if you don't remember it, write it twice and use FOIL. All right, so to square a binomial, the shortcut is a squared, so 2 squared, which is 4, and then 2ab. So 2 times negative x is negative 2x times 2 is negative 4x. And then b squared, so negative x squared is positive x squared. Okay, well, I notice now that I have a quadratic. So when you solve a quadratic, so I have the x squared. When you solve a quadratic, you need one side equal to 0. And you want the x squared to stay positive. So you're not going to subtract x squared. You're going to move 2x and 31 to the right side. Okay? So let me rearrange the order a little bit here. So let me put x squared, and then negative 4x minus 2x is negative 6x. This 4 is positive, so plus 4. And then subtract 31. Okay, once it's equal to 0, either factor or use quadratic formula. So I need numbers that multiply to be negative 27 and add to be negative 6, negative 9, and positive 3. So that means that x equals 9 and negative 3. Okay, we need to check. Okay, so I plug in 9 for x, so that's 18 plus 31 is 49. 7 plus 9. So does 9 work? No, 16 does not equal 2. Okay, 9 does not work. Check negative 3. Okay, so that's square root of 25. Minus 3. Does negative 3 work? Yes. Okay, so that says that 9 is extraneous. So it's still a solution, so don't erase it, but label it as extraneous. Okay, so check extraneous solutions with rationals or radicals, because those are the two types of equations we're solving that have issues with their domain. All other equations that we solve, your domain could be all real numbers, it could be anything, so you don't have extraneous solutions. Yes? Yes, you could. It's possible. Or it's possible to have no extraneous solutions as well. Okay? Okay. So what we're going to talk about now is solving with rational exponents, meaning you have fractions and your exponents. So I don't know what all you want to write down from this section. Whatever's going to be easiest for you, I'll talk through it, and then you write down the parts you think are important. Okay, so they're saying if you are solving and you have this rational exponent, that's n over n. So let's say you have x to the 2/3. Okay. Well, and they say m is odd, but don't worry about the odd or even just yet. Okay. Well, to get rid of this 2/3, we exponentiate both sides by the reciprocal of the 2/3, because what do you get when you multiply a fraction by its reciprocal? 1, which is x to the first, which is x. So that's how you get rid of a fraction that's an exponent. Your exponents are fractions, exponentiate both sides by the reciprocal. Okay, well, if the root of what you take to both sides, so you exponentiate both sides, if the root is odd, then you have just one answer. It's whatever the sign is that you take into that power. But if the root, so the reciprocal, is even, then you have to have plus or minus. Because when you do a square root, it can be positive or negative, or a fourth root or a sixth root. So if your denominator of the reciprocal is even, then you have to put plus or minus. And we'll look at a couple examples. So it's not what it starts out as, but the reciprocal. So if I look at number 60, and it's 3/4. The reciprocal is 4/3. The bottom, the root, is odd, so I just have my one answer. Okay, so we want to get the x by itself. So subtract 47 from both sides. That's negative 54. And then divide by negative 2. Negative 54 divided by negative 2 is 27, positive 27. Okay, so now to get rid of that 3/4, I exponentiate both sides to what power? 4/3. Good. So the reciprocal, which is 4/3. So the root, the 4/3, the root, the denominator, is even or odd? Odd. So I just have one answer. Okay, so then I get x. So you can type 27 to the 4/3 in your calculator if you want. But what we're doing is the cube root of 27 to the 4th power. So that's 3, and 3 to the 4th power is 81. So, if you type this in your calculator, on my graphing calculators, or if you have an old one, make sure you put your 4/3 in parentheses. Okay. All right. If you have an odd root, so cube root, then you do not have extraneous solutions. Your domain is all real numbers. You should still plug it in to check that you did your algebra right, but it is not going to be extraneous. If it's an even root, that's when you would have like square root, then you could have extraneous solutions. So let's look at another one. So which ones do we have to check? So anytime you have a radical, you should check. Anytime you have a rational, like the variables in the denominator, you should check. Just the exception with the radicals, you can still check every single one. If it's an odd root, like cube root, then you don't have to check those. Only even roots will give you extraneous solutions. Okay. So, what should I do first? Yeah, subtract the 29. That's negative 48. And then what? Divide by negative 3. Okay, how do I get rid of that exponent? Take both sides to what power? 5/4. So I'm exponentiating by 5/4. Is my root even or odd? Even. So that means that I have to have plus or minus in my answer. So I get x minus 2 on the left, and then 16 to the 5/4 power. So you're doing the 4th root of 16, which is 2, and 2 to the 5th is 32. Okay, add 2 to both sides. So that is 34 and negative 30. Since you had an even root, you should check these answers. They both work. But you should check them since you have an even root. You're getting it to work out. Okay. Questions about that? All right, now we're going to look at a new technique to solve equations of quadratic form. So these last few, this is the last part of the last section of this chapter. So you would expect that these would be a little bit harder, okay? They are a little bit harder. So hang in there. Ask me if you have questions as we go through. So I have a quadratic form because I can rewrite it as a quadratic. We do a technique, it's called substitution. So if any of you go on and take calculus, you will do lots of substitution and calculus. Okay. So what I want to do is I want a quadratic, and I'm already using the variable x, so that's why it's called substitution, because we pick a new variable. So I want it to look like this. I want it to be, so quadratics look like this. So instead of variable x, I have u. But I want u to be in the middle, and I want u squared to be the first term. So when I go to do my substitution, I want my u to be here, and I want this to be u squared. So I'm just going to say let u be x to the 3 halves. Okay? Hang in there for now. So I'm replacing x to the 3 halves with u. Okay? I want this to be u squared, and it'll work out like that, because if I square both sides, so from here I square both sides, okay, you multiply, 3 halves times 2 is 3. So now I get to substitute u right here and u squared right here. Okay, so I get to substitute, and so now I have u squared minus 9u plus 8 equals 0. Yes?
Why did you choose x to the 3 halves?
Because this is where I want u. So if it were a quadratic, u to the first, u would be right here in the middle, the middle term. Yes, yes. So if you're supposed to use u substitution, you want u to be the middle one. And then if it's quadratic form, u squared will be this first term. Okay? So I wanted this form because then what can I do? Factor. I can solve this equation. I can solve this equation. So let's factor it. So multiply to be positive 8, adds to be negative 9. Negative 8 and negative 1. So u equals 8 and u equals 1. Okay? Yes, are we okay with the solving in red? Okay, but my variable was not u. What should I be solving for? So now I can back substitute, I can resubstitute, and put in my x. Okay, so now I'm going to take what u is and substitute it in for these u's here. Okay, so this okay, so u was x to the 3 halves. So I have x to the 3 halves equals 8, and x to the 3 halves equals 1. So I'm re-plugging in what u was. Okay, so what should I exponentiate each side to? 2/3. Is my roots even or odd? Odd, so just one answer. So at 8 to the 2/3, so cube root of 8 is 2, 2 squared is 4. Same thing here, 2/3, 2/3. Cube root of 1 is 1, 1 squared is 1. We did an odd root, so we shouldn't have any extraneous solutions. You still can check to make sure your answers are correct by plugging it back in. But they'll both work. Okay. So questions about that one here? All right, we're going to do another type, another use substitution, okay? Okay. I want you to be the middle. I want you to be the middle. So I want you to be this whole thing here. Okay. So it's quadratic form because then u squared would be x squared plus x squared, which that's what your first term is. This will be u squared. So now rewrite it with the u's. So I have u squared minus 8u plus 12 equals 0. Okay. Solve by factoring. Multiplies to be positive 12 and adds to be negative 8. Negative 6 and negative 2. So then u equals 6 and u equals 2. Okay, back substitute. So plug in then what you had set u equal to at the beginning. So x squared plus x equals 6. X squared plus x equals 2. So how do you solve this? What should you do? So subtract 6, so it's equal to 0, and it's because it's a quadratic. So we want to solve by setting one side equal to 0. And factor. So let's see, it's going to be plus 3 minus 2. So x equals negative 3 and positive 2. All right, same thing over here. So it's going to be plus 2 minus 1. So negative 2 and positive 1. Did this equation have any radicals? Did it have any roots? No. So no extraneous solutions here. the middle term, not the coefficient, just the variable part. And then u squared was the first term. Solving then for u is what we did here in red, so that's just a quadratic that factored. And then we had to go back and plug in what we'd originally set u equal to so we could solve for x. When we have x squared, that's a quadratic, so we wanted one side equal to 0, so then either factor or use quadratic formula. Questions about any of the parts here? Okay, I'm going to do another one. This time it's a little tricky to see. So it's not set up in order, so not trying to see what the middle term is a little bit tricky. So it always goes like these quadratic forms. You always have your degrees go from greatest to least. So like here, 2, 1, and then 0. Here, 3 is larger than 3 halves. Okay. So I have to figure out which one would be the larger degree. So this is a 1. What is the exponent as a square root? 1/2. So what I have is this, 2x to the 1/2 plus 8 equals 3x to the first. So which one is the biggest? Is it x to the 1/2 or x to the first? X to the first. So the x to the first should be the first term. And we always like our leading coefficient to be positive. So I'm going to subtract the 2 square root of x and the 8. I'm going to subtract that to the right side. Okay. And then I'm going to subtract 8. Now it's set up to do the u substitution. So what should I have u equal? Square root of x, which means u squared will be x. Square both sides, it's just x. So 3 u squared minus 2 u minus 8 equals 0. I just wrote the 0 on the right side. Okay, this can be tricky to factor because your leading coefficient is at 1. So feel free to use quadratic formula if you want, but it does factor. Okay. So check your outer and inner. So I'm going to try 4 and 2 for 8. If I put 4 on the outside, then my outer would be 12, and then my inner would be 2. That's going to get me to 2. So if I switch that and I put 2 on the outside, my outer would be 6, and the inner would be 4. So I can get 2 from 6 and 4. So 2 and 4. Negative means one's negative and one's positive. I want the 2 to be negative, so that means I need my 6 to be negative, and then the 4 to be positive. And I say 6 because the outer would be 6. 3u times 2 is 6. Okay, so here I have u equals negative 4/3, right? So if you set that equal to 0, subtract 4, divide by 3. And here I have u equals 2. Okay, back substitute. Okay. Well, square both sides to get rid of your radical. So if you square a negative, it's positive, and you get 16 over 9. And then here you get 4. Right, because we're going to square both sides. Did this have radicals in it? Yes, so you have to check. And when you check, you find that this is extraneous. You could actually tell it's going to be extraneous from right here. Because when you square root, the radical's already there for you, okay? So there's not a plus or minus here. The radical's already there, so this would have to be positive. The domain of square root of x has to be greater than or equal to 0. So that's why it can't equal a negative. But that might be hard for some of you to see. So if you plug it back in, you'll see that it doesn't work. So square root would be positive. So this is why it doesn't work, because then you square root, you get 4/3. So that's 16 over 3. That's 8 over 3 plus 24 over 3. That is 32 over 3, which does not equal 16 over 3. The other one works. This works just fine. Okay. So we're going to look at this same problem, but let's look at it the way we solved with radicals earlier, by getting the radical by itself and squaring both sides. So this is without the use substitution. So isolate the radical. So subtract 8 from both sides. So it's not going to be very pretty this way either, but maybe you understand this better. Okay, divide by 2. So the reason why it's not going to be pretty because 3 isn't divisible by 2. So you get 3 halves x minus 4. You divide by 2. And then square both sides. I have this binomial squared. So 3 over 2 squared is 9 over 4. X squared. All right, 2ab. So 4 times 3 halves is negative 6. Negative 6 times 2 is negative 12. And then you square your 4, that's 16. You can write it twice in FOIL, you'll get the same thing. Subtract x. And then maybe use quadratic formula here, or if you multiply through by 4, you could factor it. But then you end up with your same two answers, 16 over 9 and 4, but that's extraneous. Okay? So I'll put a note here about quadratic formula. Okay, so that is where we'll stop. So this was a hard problem. Some of these were really hard. When you're doing these on Schoology, so the Schoology assignment's only 8 questions because it's just over 1/6. You might need to look at your notes and the book examples. You might need to practice some of the problems, the odd ones, in the book first. you could check those answers to know that you're doing it right before trying all these in Schoology.